video lesson for 5-3, graphing radical functions. We're not going to really spend a whole lot of time on this one. Most of what we're going to do is going to be using the calculator, so I do encourage you to use Desmos or your graphing calculator, some other type of graphing technology to graph these. Some of the essential things that you'll need to know whenever we graph radicals, you'll need to know what the domain is, what the range is, how to make a table of values, and then how to actually graph your equations. So here's our essential question. How can you use what you know about transformations of functions to graph radical functions? And we're going to be looking at really in example 2. So example 1 says graph the following functions, because there is a part B that goes along with this. What are the domain and range of each, and is it increasing or decreasing? So I'm going to make a table of values here. And this is a square root. We're only graphing the real values. So x cannot be anything that would make what's inside the square root negative. One of the easiest ways to figure out what x to start with is take what's in your radical, so the radicand, and set it equal to 0. And if we do that, we get back 0 for our x value. When I plug 0 into the problem, I'm going to get back 0 for my y value. So 0, 0 is actually where I'm starting with this question. You can go through and pick values of x. You don't necessarily have to pick values that are at lattice points. If you're looking at the PDF for this, you'll see that I did pick values that I could take the square root of and not get back a decimal, but there's nothing wrong with decimals if you want to do that. For example, if I use those as my values that I'm going to graph, 1. So if I put in 1 for x, I have the square root of 3 times 1 to the square root of 3, which is about 1.7. It's not necessary to put all the decimals, because if you're graphing, especially by hand, 1.7 and 1.73, they're going to look like the same thing. If I plug in 2, that's going to be the square root of 6, which is going to be about 2.4. If I put in 3, that's going to be the square root of 9, which is just 3. And if I put in 4, that's going to give me the square root of 12, which is about 3.5. So when I graph those, 1 is going to be up at 1.7, so about right there. 2, 2.4. 3 is going to be up at 3. 4, about 3.5, and it's going to keep going, and you'll see I just have this arc that's going to be going off to the right. Now, this does keep increasing. The rate that it increases is going to get smaller and smaller, but it is going to keep increasing. It's never going to plateau like our exponentials did back in chapter, or not exponentials, but the like we had with the asymptotes in chapter 4. So do know that this does keep increasing, and because the y's are getting bigger, we would say that this one does keep increasing. Your domain, so my x values are getting continually bigger, so my domain is going to start at 0 and go to infinity. My range also starts at 0 and goes towards infinity. If your function was decreasing, that is going to cause the range to reverse. So you're going to start at negative infinity and then go up to whatever the value is that you start your table at. In part B, we have a cube root. So we have the cube root of 2x. So still the 2x, but now I'm looking at a cube root. And I'm going to graph this one. Usually it's a good idea to get about 5 values to get a good picture. You do want to consider, though, especially depending on where your problem is, what value would make the radical equal to 0. So you can still set what's inside equal to 0. It's just that should go in the middle instead of at the top. There's no limits on cube roots because you can take the cube root of both a negative and a positive number. So I'm going to have both negative and positive x's here. When I plug in the 0, I do get back a 0. When I plug in, let's say, a 2, I'll do negative 2, and I'll do negative 4 and positive 4. And I picked 4 specifically because I know I can take the cube root of 8. So the cube root, if you're using a graphing calculator and you press the math key on the left-hand side, cube root is actually option 4, or you can raise to the 1/3 power, that's the same thing. So if I plug in 4, 2 times 4 is 8, the cube root of 8 is 2. If I plug in 2, 2 times 2 is 4, the cube root of 4 is about 1.6. And then of course I have the 0. If I plug in the negative 2, 2 times negative 2 is negative 4. The cube root of negative 4 is negative 1.6, or 1.587. And then plug in the 4, I get the cube root of negative 8, which is negative 2. That's going to be enough to get a pretty decent picture of what's going on here. So we have, I'm going to put my 0, 0 on here. 2 is up at about 1.6. 4 is up at 2. The negative 2 is negative 1.6, and then down at negative 2. If you, get the proper spacing with those, 2, negative 1.6, 4, negative 2. So this is kind of look, it's almost like a really stretched out S for the cube roots. This one is also increasing. To tell whether it's increasing or decreasing, it's whatever the right-hand arrow is doing. So since this right-hand arrow is going up, that's why it's increasing. The domain and range for cube roots are always going to be the same. Because there's no limits on how high or how low you go, the domain and range are always going to be all real numbers, which is negative infinity to infinity in interval notation. So here's your concept of a radical function. And radical functions, just like every other type of function we've looked at, you can put them in a format that involves an h and a k, where h is your horizontal translation, so that's going to be your left and right movement. K is your vertical translation, that's your up and down, and then a is going to be a stretch or a compression. You do sometimes have a number on the inside, that's why the 2's kind of stretch those out horizontally. Normally we would say that's going to be a vertical compression, but it was actually a horizontal stretch because it was acting on the inside. So this question is asking you to use that information to kind of tell what's going on here. I am still going to make a table of values, and I'm not as much worried about the transformations. I really want to look at the domain and range and figure out how to set up our table. You can still take what's in the radical and set that equal to 0 to figure out what number you're going to start with for your x column. And when we do that, we get x is equal to negative 3. So negative 3 is where I'm starting, which makes sense because if I were finding the h value is a negative 3 because this whole graph moves to the left 3 from the parent function. When I plug in the negative 3, I'm going to get back my k value, which is 5. And then I'm going to pick some other values. So I'm going to do, let's say, negative 2. I can't plug in negative 4. I have to go greater. Because if I go smaller than negative 3, I'm going to get a negative inside the radical, which is not a real solution. So I plug in the negative 2. Negative 1 is going to give me a decimal. 0 is going to give me a decimal. I'm going to go ahead and do 1 just so I can avoid some decimals there. And then we'll go ahead and do 2 just to get a picture of what's going on. So when I plug in negative 2 plus 3 is 1. Square root of 1 is 1 times 2 is 2 plus 5 is 7. If I plug in 1 plus 3 is 4. Square root is 2 times 2 is 4 plus 5 is 9. And then if I plug in 2, this is where I'm going to get a decimal. 2 plus 3 is 5. The square root of 5 is about 2.2. And then times 2 would give me about 4.4. And then plus 5. So I'm looking at like 9.4, 9.5, depending on how many decimals you carry through there. So negative 3 5 is where I'm starting. Then I have negative 2, 7, so I'm a little steep there. And then I go up to 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 2 is going to be about 9.5. So I'm coming up. Notice I am stretching this out in the vertical. It is getting rather steep here. So your domain is going to be negative 3 to infinity. Your range is 5 to infinity because this is increasing. If your arrow was pointing downward, it would be negative infinity to 5. So it says, how do the domain and range of G differ from those of F? Well, F is 0 to infinity, so this graph has moved to the left 3 and up 5 from the parent function, and it's 2 times as steep. So that's all we're really going to talk about for 5-3. Again, it's not a very involved section. You can use Desmos to help you graph. So go back through, watch this. If there's anything you're not sure of, please make sure you reach out and ask some questions.